The first thing we'll cover in this tutorial is visualizations. We had already seen the cross-sections and map visualization. To visualize boreholes, just type a name, click the boreholes visualization, click the dataset to visualize, and submit. In the top left of our window, we will be able to switch between visualizations. Clicking boreholes will show us our boreholes colored by unit. Depending on our device, we can browse a visualization, zoom it, etc. Another important visualization is the interpolated faults. This visualization does not need parameters. Right now, we only have a single fault and a single cross-section. This fault gets extrapolated through the bounds of the model. Other visualization is the block model. In this case, you will need to delineate a polygon where the block model will pass. Click the points you need and finally click the start point. Fill the bottom C coordinate and the top C coordinate of the model, or a large number to use the topography. The block model will be generated using the interpolation of the available cross-sections. With a single cross-section, GeoModeler extrapolates folds and polygons perpendicular to the section. The next visualization is a combination of others, so we can see several things at the same time. Write a name, select all the visualizations you want to add, and submit. This combination shows boreholes, faults, the cross-section, plus the block model we just created. Non-unit is semi-transparent. This unit is special that it does not get interpolated. The interpolation algorithm fills all the space with the nearest unit, in this case, flim-flam. Let's delete this visualization. Let's create another that contains only boreholes, cross-sections, and faults. This will be the visualization we will use to evaluate how our model is going. We'll come back here from time to time. Let's finish our cross-section. If you need to refresh the concepts of the editor, go back to the previous tutorial. We will be fast-forwarding through this. We'll model the most important faults and also the most important formations. The most important formations are flim-flam, Hidden, Lewis, and Missy. The most important faults are Flim-Flam Lake, Tailings Pond, Lower Catherine, Ross Lake, and Channing. This part of the regional geology depicts an anticline, with Flim-Flam Formation in the middle. Flim-Flam is also the formation where the ore body is. Faults are assumed to be very rect, with an inclination of about 70 degrees. We will also be modeling the intrusion, symvolcanic, pre-Missy, post-Missy, and Onazine. After finishing the first cross-section, we will create our first interpolated cross-section. The first thing to notice is that GeoModeler won't let us create a cross-section that's not parallel to the previous. Cross-sections that are part of the interpolation need to be parallel. Selecting Create an interpolated cross-section will extrapolate the previous. We see that the cross-section we created is just a copy of the one before, but it's a start. Let's modify this cross-section in the regions that we need. We see that the surfaces are a bit off. We have to move a bit the faults and the units so that the model reflects the contacts in the surface. Remember to name the faults correctly, as they are only interpolated if they have a name and if it corresponds with its neighbor. After finishing the changes, we can go back to our study. In our study, we will create a third cross-section. This cross-section will be in the middle of the first two. The interpolation will have to show a smooth transition between AA and BB. It's important to create the section using the same branch as the other two, as only contiguous sections get interpolated. We'll have to make a few adjustments to the cross-section, but this time they will be fewer and fewer. Units get interpolated when there is a unit in the next section that is intersected with this one. If a unit is single and does not have a couple, it will have a buffer around the section to keep the smoothness. We can also use all the information that we have available to corroborate that the cross-sections are being interpolated correctly. For example, we can use boreholes information, etc. When we are ready to continue, we can save the cross-section and exit. Let's go back to view how our model is going. We can view it together in the visualization we created previously. Before we go back to the visualization, we have to rebuild our faults, so they take information from our new cross-sections. We see that there is one fault that's not fully triangulated. Let's go back to cross-section CC and let's check if it's correctly named. Let's name our fault correctly as Ross Lake fault, and after that we can go back to check the triangulation of the faults. Let's rebuild, so we can see that our faults now are full and we can keep working in our model. After that, let's click in the combined visualization so we can check how our model is right now. We can view all of our fault planes and our cross-sections using interpolation refinement. I have completed the regional model. Now the model has 6 cross-sections and the intrusions are better modeled. For pretty much any 3D modeler, those intrusions would be a great difficulty. So let's understand better what interpolation does. Let's create our first cross-section that's not parallel to the others. What we draw in this cross-section will not be taken as information for the interpolation. However, we can use the interpolation to draw this cross-section. To be able to draw it, you must select cross-section in 3 directions. Finally, put the bottom C coordinate and click to interpolate the geology and submit. We can check that the cross-section was correctly created. To view it with the rest of the cross-section, let's go to visualizations. The interpolation algorithm takes a pair of contiguous cross-sections and pairs the polygons with the same unit depth intersect. It then creates a smooth transition between polygons. We can see that all the contacts that the cross-section traverses coincide with the parallel cross-sections. We can also see how faults create discontinuity in the geology, as we would expect. As we refine, new cross-sections get easier to make. Let's begin to model what's important to us, the ore body. Flin Flon has massive deposits of copper and zinc. There are several massive sulfide deposits, like Flin Flon, which is open and can be seen in the map. There is also 777, Cullinan, Mendy, and Skislake, which are underground. This tutorial will go until we finish modeling Flin Flon deposit, but modeling the rest of the deposits should have the same steps. The most important tool we have for this are the boreholes. The way in which we obtained the boreholes is that we extracted only information with stratigraphy, plus the massive sulfide ore. That means boreholes will look cut, and there will appear a lot of black circles, which are the heads of the boreholes that did not have stratigraphy and weren't ore either. We have refined 2 cross-sections at important points of the open pit. As we create more sections, we see that the ore body starts to interpolate like we want. Also, the divide and join operations are very useful to refine when we compare it to having to create horizons with no topology relations. Let's create a new cross-section, JJ. The naming convention I used was in the order I created the cross-sections, so I would remember which section was interpolated from which. GeoModeler orders the parallel cross-sections according to their location. That means that 2 contiguous cross-sections will be contiguous when we check them in the study previews. A last cross-section will be located at the end of the deposit. As this cross-section will be the last of the deposit, the R body will not have any relationship with the next section. However, GeoModeler will create a small buffer so that the interpolation does not look like having very weird ends. Finally, let's create the cross-section of our deposit. This cross-section will be in a free direction. By clicking options in the visualization, we can hide and show surfaces, like the cross-sections or the map. We can view that our deposit is now completely contiguous. We will need more cross-sections to model it. Let's create a new cross-section where it's missing information. This will be named LL. We will use boreholes to refine this cross-section further. Finally, we will create a section called MM. This section will help us to refine the deposit more so that the next time we test the interpolation, it will be like we want it. The boreholes of this cross-section show very clear the direction of the deposit. Finally, let's create a new cross-section to evaluate flim-flam deposit again. This cross-section is in a free direction. It will traverse flim-flam deposit. With these cross-sections, our model should be well defined and ready. Next tutorial will show what we can do with our model after this.